Hello and welcome to Data Analytics with Layla. In this week's video, we are diving into the world of big data technologies and understanding why they are essential. We'll start with a quick recap of the 3 V's of big data fundamentals from last week: volume, variety, and velocity, and discuss the challenges each presents. For each challenge, we'll explore the technologies used to address these issues, like Kafka, Spark, and Hadoop. This approach helps us learn not just about the technologies themselves, but also why they are pivotal in managing big data effectively. So, stay tuned and let's begin our insightful journey together. Last week, we started our journey into big data, looking at the big three: volume, velocity, and variety, and the challenges they bring. Missed it? No worries. Just hit the pause and click the link below to catch up. It is important to get these basics down before we move on. Remember the tricky parts we talked about with each V? Well, this week we are switching things up and diving into the cool tech that's being built to handle these challenges. We are not just going to throw a bunch of tools at you. First, we'll chat about why we need these technologies and the specific problems they are solving. Plus, we'll dig into some key ideas that all these technologies share. Super important for anyone getting into big data. So, let's get ready to connect the dots between big data concepts and the real-world tech that makes it all work. Let's go. Let's chat about the volume part of big data. Imagine having to cram millions of books into your living room. Sounds impossible, right? That's kind of like what happens when you try to stuff huge amounts of data into the traditional computers. They just can't handle it. But don't worry, there's a clever solution called distributed computing. So, what is distributed computing anyway? Picture this. Instead of one overwhelmed library, you have a bunch of smaller, connected libraries. Each one holds a part of the entire collection. That's distributed computing for you. We break down the data into smaller pieces and spread it across the different computers or nodes. It's like having a team of mini libraries, each one ready to quickly find and share its own books. This way, we solve the storage headache and make fetching data a breeze. Ever heard of Hadoop distributed file system? Let me give you a cool example. There is this thing called the Hadoop Distributed File System, or HDFS for short. It's a star player in the world of distributed computing. HDFS is all about storing super large files across many computers. It chops up the data and spreads it out. The cool part? Even if one computer takes a nap, breaks down, the data isn't lost. We can still get it from the other computers. Why do we love distributed computing for big data? Here's the deal. Distributed computing is like a magic trick for big data. Need more space? Just add more computers to the network. It's like building more shelves into our mini libraries whenever we need. And guess what? These computers work together, each handling a piece of the puzzle. This teamwork makes processing data way faster than asking one supercomputer to do everything. Let's talk about the velocity aspect of big data. Imagine data zooming at us like cars on a highway. That's velocity for you. Data coming at us super fast and needing to be processed right away. In our digital world, where data never stops flowing, the real challenge is not just storing it, but keeping up with its speed. So, what is the deal with the real-time data processing? Think of it like catching and juggling balls as they thrown at you. We need to grab and understand this data as it comes, in real time. That's where some cool technologies come into play. Meet Apache Kafka for data streaming. First up, Apache Kafka. It's like a super efficient post office, handling tons of letters or data at lightning speed. Kafka is great for collecting and managing real-time data, like clicks on a website or online purchases. And then there's Spark Streaming for instant analysis. Next we have Spark Streaming. Imagine it's a super smart robot that can sort and analyze data in tiny batches super quickly. It's like having a mini brain that processes each piece of data as it arrives, making sure that we don't miss a beat. Kafka and Spark Streaming, a dynamic duo. When we combine Kafka and Spark Streaming, it's like forming a superhero team for data. Kafka handles the fast-moving data, and Spark Streaming jumps into the analyze and it on the fly. This combo is perfect for things like stock trading or detecting fraud as it happens. Real-world example. Let's take an online shopping site as an example. Imagine it using Kafka to gather all the clicks and searches you make. Then Spark Streaming analyzes this data in real time to suggest products you might like. It's like having a personal shopper who understands your taste instantly. This kind of real-time processing is also super important in other areas like social media, telecom, and even in cars that are connected to internet. Let's talk about the variety aspect of big data and its challenges. It's not just about the size or speed of the data, but also its diverse forms. We are talking about everything from neatly organized, structured data to more free-flowing, unstructured data like texts and images and videos. The real challenge? Making sense of this diverse data landscape. Now, let's look at some of the technologies that help us manage this variety. Apache Kafka for diverse data streams. Apache Kafka is a versatile player in our big data toolkit. It is not just great for handling fast data streams, but also shines when dealing with different types of data, whether it's structured, semi-structured, or unstructured. Kafka can handle it all, making it a go-to for diverse data scenarios. NoSQL database for flexibility. When it comes to storing and managing different data formats, NoSQL databases like MongoDB are invaluable. They offer the flexibility needed to work with various data types, especially when dealing with semi-structured and unstructured data. Unified processing with Apache Hadoop and Spark. For analyzing large data sets of varied formats, Apache Hadoop and Spark are our heavy hitters. These frameworks are designed to process and analyze data regardless of its structure, helping us extract valuable insights from our diverse data pool. In practice, social media analytics. Let's put this into context with a social media analytics example. Imagine a platform that collects all sorts of data, from text posts and metadata to images and videos. Kafka would be used for data ingestion, MongoDB for storing this varied data, and Spark for processing and analyzing it. This combination allows for comprehensive insight into user behavior and trends on social media. As we wrap up our journey through the world of big data, it is clear that the challenges are as vast as the data itself. But guess what? With all these cool technologies and tools at our fingertips, we are more than ready to tackle them head on. Think of it like a toolbox. Each tool we have talked about, from Kafka to Spark, Hadoop to NoSQL databases, has its own superpower in handling big data. As you get hands-on with these tools, you'll start to see how they work their magic on different big data challenges. And here's the exciting part. The big data landscape is always changing. New technologies pop up, bring new solutions, and of course, new challenges. It's like a never-ending puzzle. But don't worry, the basics we have covered give you a solid foundation to build on. For those of you hungry for more, check out the additional resources in the description below. They are packed with info to help you dive deeper into the tools and technologies shaping big data. So keep exploring, keep learning, and who knows what amazing insight you'll uncover next in this thrilling field. Next.